All right, guys, so this is the video for the notes for day one of reviewing quadratics. And as I've kind of explained in class, on a normal, typical year, this may be review, but honestly, with the school year cut short from last year, with COVID, I don't know that you guys got this or not. So this might be new, I don't know. So the reason we're reviewing it is because you will need it to solve some problems we use for chapter 10. So rather than stopping in the middle of chapter 10, since we have a few days before spring break, we're just going to do it now. That way when we get to chapter 10, we can keep rolling. So the goal over the next 3 days is just to kind of understand how to solve these, and hopefully it'll be some low stress type stuff. But if you have any questions, please do ask. All right, so we're going to talk about quadratic equations. Okay, now a quadratic equation is simply an equation when the highest power, and I'm going to put in parentheses exponent, is 2. Okay, so anytime you have an equation and there's the highest exponent is a 2, that would be a quadratic equation. Okay, and anytime we have a quadratic equation, we write it in standard form. So y equals, it's ax squared plus bx plus c, and I'm going to put here where a cannot equal 0. Okay, the reason I put that is because if a equals 0, then it's just a linear equation because we don't have an x squared. Okay, so when I do this, notice that the a is always the number, or I'm going to be a little more correct, the coefficient of the x squared. The b is the coefficient of the x, and the c I'm going to put here as the constant, or in other words, not attached to an x. Okay, and we'll do some example problems. Not that you need to know it for this chapter or for this class, but in Algebra 1 you should have learned that when we have a quadratic function, if a is a positive coefficient, it looks something like this. It's like a U, and it's facing upward, or it's opening upward. And when a is negative, it faces down. Okay, what we're going to be focusing on is mainly how to solve these. As of right now, we don't care too much about the graphs. All right, so when we're talking about writing something in standard form, and finding the a, b, and c, so when I write it in standard form, guys, we want to write it with the exponents in descending order. Okay, so we want to find the biggest exponent first. So here, notice the x squared comes first. So to write it in descending order, I'm going to say y equals x squared. And then next is just the x, so plus 3x, and then the minus 5. Okay, now my a, b, and my c are my coefficients in front of these. Okay, so I can say that my a, remember we have ax squared plus bx plus c. So my a is always the number in front of the x squared. So if there's nothing here, think of this as a 1x squared. So my a is just 1. My b is always the number in front of my x. So my b here is 3. And my c is always my constant, which is -5. All right, so let's do another one here, okay? So I always like my y on the left. It doesn't have to be. So I'm going to say y equals, okay, decreasing in power. So my negative, don't drop this minus sign, -9x squared. If you want, you don't have to. We don't have an x, so you can write 0x if you want to, if it helps you. And then -5 is your constant. So you can write this, or you can write y equals -9x squared minus 5. These are the same thing. You'll see it more like this. You'll hardly ever see it like this, but as you're learning your A, B, and C, if you want to put 0 in the place value, that's fine. Okay, now from this, we have our A, number in front of the x squared, is a negative 9. Our B is the number in front of the x. We don't have an x, or we have a 0x, so it's 0. And my constant, which is my C, is my negative 5. Once again, don't drop this negative. All right, so I want you to go ahead and pause this video. Go ahead and try to do C on your own, and then we'll go over it. So write it in standard form, and then write your A, your B, and your C. All right, so if you worked this one out, you should have gotten for standard form y equals 7x squared plus 5x minus 1. Okay, so this minus 4 plus 3 just turns into a minus 1, which makes your A your 7, your B is your 5, and your C is your negative 1. All right, now let's go through, and I'm going to teach you how to factor these. And when we factor them, we can solve them. So we're going to learn 2 ways to solve these, and there's several different ways out there, and you'll learn them all in Algebra 2. You'll learn how to do everything in Algebra 2, but we're just going to learn 2 ways. Okay, so we're going to learn by factoring, so we're going to spend 2 days on factoring, and then we're going to learn how to do it using the quadratic equation. So here, we're going to learn how to factor when my A is equal to 1. Okay, now this is a very big deal. So my A has to be equal to 1. So as you're looking here, you're thinking, well, my A is 3, not 1. Okay, we'll get there. All right, so I have written these steps down, and this looks like a lot, but really it's not. You'll get to where you don't need to look at these steps. Okay, but I'm going to follow the steps at first just so you understand them a lot better. All right, so step 1, write the equation in standard form and set the equation equal to 0. Okay, so what that means is I want this all equal to 0. So I'm going to subtract 33x from both sides. If I subtract it from one, I have to subtract it from the other. So I'm left with 3x squared minus 33x plus 72 equals to 0. All right, so that's step 1. Write one here. So step 2, I'm going to factor out this GCF is greatest common factor. Okay, and I'm going to factor a greatest common factor out. So if I look at these and I look at the coefficients, 3, 33, and 72, I see that 3 can go into each one of these, okay? So since 3 can go into each one of these, basically I'm going to factor a 3 out, okay? So I'm left with 3 parentheses, x squared minus, well, 33 divided by 3 is 11x, plus 72 divided by 3 is 24, equals to 0. Okay, now I'm just concerned with this quadratic equation here. Okay, I don't care about this 3 up to this point. All right, so that's step 2. So step 3, I want to find 2 numbers that multiply to A times C and add to B. Okay, so let's identify our A, our B, and our C. So our A is, if there's nothing in front, it's just a 1. Our B is negative 11, and our C is 24. Okay, I always write this in an X. So I want 2 numbers that when you multiply them, they equal to A times C. So A is 1, C is 24. 1 times 24 is just 24. So they multiply to 24, and they add to B. So they add to B, which is negative 11. Okay, so I'm going to go over here and I'm going to find all the factors of 24. So I have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then other way around. Okay, so if I look at this, they multiply to be a positive number and they add to be a negative number, which tells me both of them have to be a negative. Okay, so I want to know, if I make both of these negative, which ones add to negative 11? Right here. Negative 3 and negative 8 do. Okay, so I found, this is my step 3. 3. My 2 numbers are negative 3 and negative 8. All right, so step 4, now I'm going to factor those two numbers to parentheses that look like this. So I can't forget my 3 up front, so my 3 up front. Now this whole thing here is going to change. A plus n, A plus m. So I'm going to make this m and this n. It doesn't matter. It can be this, can be n, this can be n. It doesn't matter. Okay, so I have a plus a negative 3 or just a minus 3. And then a plus a negative 8 or a minus 8. Okay, or I guess here I'm doing x. Let me change this to x and x. X and x. And that's going to equal to 0 still. Okay, now my hard part's done. This is factored. Okay, now I want you to think about this. Here, we're multiplying 3 numbers. We're multiplying 3, then whatever number this is, and whatever number this is, and it's going to equal 0. Okay, so when is the only time you can multiply 3 numbers and they equal to 0? The only time we multiply numbers and it equals 0 is one of them has to be 0. Well, 3 is never going to be a 0. Okay, well, so I want to say, well, when is x minus 3 equal to 0? Because when x minus 3 equals 0, this parentheses is 0, and this would give us 0. Okay, we'll add 3 to both sides. I get x equals 3. Okay, now I want to go over here. When does x minus 8 equal to 0? Add 8 to both sides when x equals 8. So anytime I have a square, a quadratic function, that tells me I get 2 solutions. Here are my 2 solutions. All right, let's do another example. So I want to write this in standard form, set equal to 0. So x squared plus 9n plus 18 is equal to 0. Okay, factor out a GCF. I don't have a GCF. Coefficient of this is 1. Okay, so find 2 numbers that when you multiply, they multiply to a times c. Well, my a is 1, my c is 18. 1 times 18 is 18. And they add to b, which is 9. So 2 numbers that multiply to 18 add to 9. So if I factor 18 out, 1 and 18, 2 and 9, 3 and 6, and that's it. Okay, well, both of these have to be positive. So if I look at these, which numbers when I add, they add to a positive 9 right here. So my m and my n is plus 3 and plus 6, or just 3 and 6. Okay, so now I'm going to factor it. So I'm factoring this long thing here into 2 parentheses, and it's going to be x plus 3 and x plus 6. Okay, now I'm going to ask myself, when will this parentheses be equal to 0? So when is x plus 3 equal to 0? And then when is this parenthesis equal to 0? Well, just simple algebra, minus 3, x equals negative 3. That's one of my 2 solutions. Minus 6, x equals negative 6. Here's my other solution. So x equals negative 3, x equals negative 6. Those are my 2 solutions. All right, I want you to go ahead, try to do C and D on your own. So both of these on your own, and then we'll go over. Make sure you follow every step, and you should get 2 solutions for each. All right, so this is what you should have gotten for C. If you need to pause this and look, please do. And then this is what you should have gotten for D. And once again, if you need to pause and check each step, please do that as well.